Hi everyone, I hope you're all doing great today. I know I am, and today we'll be actually looking at a proof. Now, this proof is a trigonometric proof. It's called the law of sines, or the sine rule if you like. You may have been taught it in school. I hope you've been taught it in school at some point. If not, this will be your first time seeing it, so I'm very excited to show you it for the first time. Now, it says that in a triangle where you've got some sides and some angles, so in a triangle like this, the generic triangle where you've got angle A, angle B, angle C, and little a is opposite angle A, little b is opposite angle B, and little c is opposite big C. I've drawn the C's the same size. That's a little bit confusing for you, I do apologise. And it says that the ratio of the sine of the angle A to A is equal to the ratio of the sine of B, the angle B here, to the length B. But how can we go ahead and prove that? That is what I'm going to be showing you in this video. Most people in the world of maths will tell you that geometric proofs are their favourite. I absolutely agree with them. I think they're very nice to do, very beautiful proofs which just involve basically drawing shapes and formulating equations from them. And to do this one, we're actually going to take this triangle here, this generic triangle with sides and angles, and we're going to draw a line down from C at a right angle with little c over here. Now we're going to label this line H for height. It could be anything. You could label it D if you want for A, B, C, D. Whatever, it's up to you. That's the beauty of algebra. And we're actually going to find H in two different ways. So the first way we're going to find H is we're going to look at this little right triangle here on the left. So we can go ahead and say that the sine of A is equal to, if you remember, the opposite side divided by the hypotenuse, which is H divided by B. And we're also going to have a look at this other right triangle here on the right hand side, and we can say that sine of B is equal to the opposite side, which is H divided by the hypotenuse A. Now we actually have H in both of these equations, so we can go and solve for H in both cases. We get on the left one, H is equal to, multiply through by B, so we get B times the sine of A. Similarly on this one, you want to multiply through by A, so we get H is A times the sine of B. Now, H is here and H is here. In this triangle we've drawn, H can only be one thing. This is not variable. H is one thing, so which means we have this equality over here. We can say that B sine A is equal to A sine B. Now all we have to go and do is divide through by B and divide through by A. So we get that sine A divided by A, because the B's have gone and we've divided by an A, is equal to sine B divided by B, because the A has been cancelled out and we've divided by B. And this is our answer. This is what we have proven. You can actually go one step further. You can actually simply just relabel the sides. You can relabel the sides, or you can just draw another line. Either way it works. And you get that this is also equal to the sine of C divided by C. But this is implied. You can quite easily see that. So this is a nice geometric proof of the sine law, and I hope that helps.